Hey students, Mr. Roberts here. We are continuing our study of ratios, and today we're going to go over another strategy that is called ratio tables. Now, yesterday we talked about using tape diagrams to model ratios, and it's a great strategy, especially if you like to see how everything's broken down in a ratio. Now, ratio tables kind of take that model away and let us just deal with the numbers that we need. So some people prefer this. It's up to you as an individual to kind of choose the strategy that you would like to use. And we are working our way up to another strategy tomorrow, or actually it's going to be next week, and we'll be using a proportional relationship to describe a ratio. And so let's get to it. All right, to begin with today, we are going to look at bell work. And I would like to look at this one. This one goes right in line with ratio because we are comparing a total with money. And a unit rate is a ratio. Now, I'm going to set these up as ratios. And we're going to kind of see how it works. So whenever I say the word unit rate, like right here, unit rate, we are talking about how much it is for one. So we are trying to find out how much it is for one of whatever is being discussed. So here we go. We are going to look at this problem right here. There is, and the way that I think that we need to set up unit rate problems is the money always goes on top. So I'm going to go $1 is 5. I want to know how much. I don't know how much this is yet. It is for 1. Okay? So right here, this is a proportion. So if you're looking at this proportion and you're thinking, whoa, that's weird, I don't know what to do. Well, there's a couple of ways we can look at this. We can look at it as, okay, how did the numbers change? So right here, we have a number that changed into 1. So how did that 5 change into a 1? Well, we divided by 5. And what we did here, what happened here has to happen up here. So if I take $1 and divide it by 5, I get 20. So it'd be 20 cents. Now you can look at it that way. Sometimes you can't see that relationship right here. So you have to do it this way. 5 times x is 5x. 1 times 1 is 1. And then I'm going to divide by what's over here and here. So I get the same answer, 20 cents. Let's move on to the next one. So, or you can, and maybe you can see this little shortcut already. Whenever you're looking for unit rate, all you really have to do is divide that by that. And it gives you the same answer. But I'm just trying to show you the ins and outs of how it is related to a ratio. So over here, we're going to do the same thing. If we wanted to go $3 for 12, I want to know how many it is for 1. Well, how did this 12 turn into 1? I divided it by 12, so take the $3 and divide by 12. It is okay to use your calculator here. And I get 25 cents. So this one is 25 cents, and this one is 20 cents. So which sale is better? Would you rather buy 5 of them for $1 or 12 of them for $3? Well, if the better buy is less money, right? So we know that this guy right here is the better buy. Let's move on to number 2. We are now looking at a ratio table. Now, the way that I approach ratio tables is I like, again, to look at how did things change? What happened to make it change? So if we started out with a 1-to-5 ratio on the top here, and now we're looking and comparing these two numbers because they are the same, and we can always call this an X and a Y. You can call it whatever you want, but I like to call, okay, we have X's and Y's. So for every 1 X, we have 5 Y's. So if I have 10 Y's, how many X's do I have? Well, how did this 5 change into a 10? I timesed it by 2. So I'm going to change, or I'm going to times this by 2. So 2 times 1 is 2. Now, this right here is the key to unlocking everything else in the ratio table. If you have the most simplified ratio, it's going to help you to unlock the rest. So, again, we can only compare things in these columns. So, how did this 1 change into a 5? I timesed it by 5, so I have to times this number by 5, and I get 25. This 5 changed into 50. How? I timesed it by 10. So I'm going to times this 1 by 10, and it becomes 10. So there you go. That is how you use a ratio table to fill in missing values. You look at change. It's important, and that's what we're going to be talking about today. Okay, so we're going to be writing an equivalent expression for each situation. All right, so I'm going to actually use the cake method here. I have 36x plus 28, and I need to look at what they have in common. I can take a 4 out of both of these, and that would change this into a 9x plus 7, and that would be my parentheses with the 4 on the outside. This one, we're going to do almost the opposite. We're going to use the distributive property and go 3 times 2x is 6x, and then 3 times 15, negative 15. I'm sorry, I don't know my 15 times tables, but we get 45. So there we go, 6x minus 45. There's your bell work. Let's move on. Okay, so here we go. We're going to start studying ratio tables now. You need to find this page in your journal. It's 5.2. It's in the green section. So if you need to pause, go ahead and pause, pull this paper out. You really need to get this out. Let's do this. 2 ratios that describe the same relationship are proportional. You can find and organize equivalent ratios in a ratio table. All right, so these ratio tables, and guys, I want to point out these keys here. If you look at these keys that are above these columns, there's a reason we have a key there. It's because it's the most simplest in the ratio table. And I alluded to this in your bell work. If you have the most simplified version of a ratio, it is the key to unlocking any other ratio that you need to find. And I cannot impress upon you enough how important it is that you are able to simplify ratios. If you can simplify a ratio all the way down to the smallest value that it can be, you're able to find out any other ratio in a ratio table. And I'm going to demonstrate that here in just a moment. So let's take a look at this number 1. We are comparing dogs to cats. For every 5 dogs, there is 1 cat. We have the most simplified version. How did this 1, and because again, we can only compare things in the same row or column, how did this become a 2? Well, we times by 2. What we do to this value, this relationship has to be the same as what is going on top. Because I times this by 2, I have to times this by 2 to get that value. So 5 times 2 is 10. Okay? What happens when I simplify 10 to 2? It turns into 5 to 1. That's the whole point of this, is that we are showing that they are proportional. Proportional means that they simplify to be the same thing. Okay, I'm going to go back to my key again, and I'm going to look here and go 1 changed to 3 because I timesed it by 3. Do it to the 5. 5 times 3 is 15. Okay, so that key value is what we are looking at. So if we are looking at this, is this the simplified version of this? No. We have to simplify it. So you can put it through the cake method if you want to, or you can look for something that they have in common. So how did this 12 turn into a 3? Well, it got divided by 4. So let's divide this by 4. So we divide the 8 by 4 and we get 2. We now have the most simplified version of that ratio. So we can figure out the rest of the values in this chart. So how did this 2, now we always go back to the one that's the key. How did 2 turn into 10? Times by 5. So I have to times this guy by 5. And I get 15. Now, this 3 changed into a 24. How? I times it by 8. So I'm going to go back up here and times this by 8. And I get 16. Okay? Ratio tables are really a good way to see a different value, a proportional relationship. Okay, so here we go. Let's go on to number 3 now. We need the key. So we're going to go, this one's kind of hard because look, I can't see how 6 turned into 16. So I can't just go that way. It's because we have to have the simplified version of the ratio. If we have that, we can see the relationship. So for this one, I'm just going to go like this. 15 and 6, I'm going to use the cake method. And I know that 3 goes into both, and that becomes 5, and that becomes 2. So now I know what goes in this box right here. I know that the 15 turned into a 5, so this turns into a 5. I know the 6 turned into a 2, so it goes here. Now I can use this to do the rest. So now I'm going to go, okay, I know, so if you want to look at it this way, I have a missing box right here. I don't know what it is. So I have this. So how did 2 turn into 16? Times it by 8. So 8 times 5, 40. All right, 5 turned into 35. How? Times it by 7. So 7 times 2, 14. That's really all there is to this, guys, is if you can, number 1, find the most simplified ratio, then you can always use what you have to find what you don't have. So really, that's all we're doing. Taking a look at this next one, we have 18 and 15, and we need to simplify that. Again, 3 is the number I'm going to choose here because 3 goes into both of them. That goes 6 times, that goes 5 times. So I know that this turned into a 6 and a 5. And now I can find out my missing values. 5 changed into 20 because I timesed it by 4, times the 6 by 4, and I get 24. Next one, 6 changed into 36 because I timesed it by 6. 6 times 5, 30. Voila. Not too difficult. Hopefully that made sense to you, but we're going to do a practice page together and get some more practice on this. So here we go. All right, we're looking at your practice page, and we need to do some problems here. So let's take a look. Books to pencils. Okay, so how many books do I have? I have 2 books. How many pencils? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 to 10. Well, it wants us to write 4 equivalent ratios. So the first thing I always do is that simplified? It's not. It simplifies to a 1 to 5. Now, it makes it really easy to go, well, we look at just multiplication tables here. So it looks like we already used 2 to get this guy right here, right? So if I times that by 2 and that by 2, I get this. So let's times it by 3. 3 times 1 is 3. 3 times 5 is 15. Okay, let's use 4. 4 times 1 is 4. 4 times 5 is 20. There we go. Let's do number 2 now. Find the missing value in the ratio table, then write the equivalent ratios. Okay, so we have 3 to 5. First of all, is that simplified? Yes, so it's now our key to unlocking the rest of the ratio table, the other ones in here. So we now can just ask ourselves, how did this 3 turn into a 6? I times it by 2. So I'm going to take the 5 and times it by 2, and I get 10. Got it. Okay. Let's go through that process one more time. Okay, is this a simplified ratio? 2 to 7. Yes. So I don't have to simplify. Now I look at the relationship. 7 turned into 21 because I times it by 3, times the 2 by 3, and I get 6. Not too bad. I mean, hopefully that's making sense to you. Let's take a look at number 4. Okay, I'm looking at this ratio. It's comparing kids to adults. You can see that these ratio tables can be vertical. This one's a vertical one, right? These two are vertical. These are horizontal ones. More often than not, you're going to run into these horizontal ones, but we want you to be prepared with vertical ones also. So this number 4 here, we look at here, there's our simplified ratio, 3 to 1. Doesn't simplify any further. So now we look at the relationship. 1 turned into 3 because it times by 3. Times 3 by 3 and we get 9. Okay, pretty simple stuff. Okay, now this next one. It's not simplified. This isn't simple. We have to simplify it. But where do we write it? You can choose kind of where you want to write this. I like to write it right here. So if this isn't simplified, let's simplify it. We get a 1 to 2 ratio. We're going to now use this for the rest of it. Because we can't just, I'm going to be honest with you. The simplified ratio works every single time. If you don't use the simplified ratio, you're going to run into issues and it's going to be harder. And you're not going to, it's not going to make sense sometimes. So how did this 1, or I'm sorry, okay, how did this 2, sorry, turn into 20? I times it by 10. So I'm going to times the 5 by 10, and I get 50. Okay, the next one, that is a simplified ratio where you don't have to simplify it. This 4 turned into a 16 because I times it by 4. So we're going to times this 5 by 4, and we get 20. This, we don't have a simplified ratio. We got a it looks like it's getting smaller. So let's see how what happened here to get it smaller, and then we can or we can just simplify it ourselves. And that's easy because we know how to use cake method, right? We know that 3 goes into both of these. That goes 10 times, and that goes 9 times. Oh, look, there's a 9 here, so I know that goes to that. So it's a 10 over 9, or a 10 to 9 ratio. So there we go with the 10. Okay, let's look at the next one. We have a 2 to 3 ratio, so that we know that is simplified. Nothing goes into 2 and 3 evenly. So we are now going to go look at the relationship. How did 3 turn into 12? Times it by 4. So I'm going to take the 2 and times it by 4, and I get 8. Okay, now we're going to look at how did this 2 become a 32? And you may not be able to see that relationship, but if you can't see the relationship, pull out your calculator and go 32 divided by 2, and it's 16. So I know that the relationship here is times by 16, so I have to times this 3 by 16. So 3 times 16 is 48. It's okay to use your calculator to figure things out like that. Let's take a look at number 9. Ooh. The only ratio that it gives us is this guy. It is not simplified. We need to simplify it. So I don't care how you do it. If you can see the relationship and you can simplify it without the cake method, that's fine. But if you need the cake method, it's always there for you. 5 goes into this once, and 5, that's 3. So I can see that this changed into this, which is the same here. So 3 goes here. Now I'm looking for relationships. See that missing box? I look for the one that's below. How did 3 turn into 75? If you think money, 25. 3 times 25 equals 75. So 25 times 1 is 25. Okay, so this is just those of you that know your multiplication tables, you're going to go through, you're going to rip through this real quick. If you don't know your multiplication tables, you may need to get out a chart or get out some sort of calculator to help you to get through this. So we're on our last questions on this practice. It says, for every 2 cars you wash, your friend washes 3 cars. You wash a total of 8 cars. How many does your friend wash? Okay, so you can look at this however you want to. We know that you did 2, your friend did 3. Okay, and you know that if you do 8, how many does your friend do? You can fill in this whole table if you want to. Or you can look at this relationship thing that I've been talking about and go, okay, how did this 2 turn into an 8? Well, I times it by 4. So take this 3 and times it by 4, and it'll give me 12. And there you go. That's how many car washes that your friend did, is 12. So you're looking at this relationship. You don't have to fill out a huge chart all the time. If you have is this the simplified ratio? Yes. If you have a simplified ratio and you know one of the other numbers, right, like this, you can find out any missing number. So let's look at the last question here. Your closet has 5 shirts for every 2 sweaters, and that's shown here in the chart. Your closet has 30 total. How many sweaters are in your closet? So if you can see this relationship, do you have to fill out the whole table? What is it? It only wants us to show how many sweaters are in your closet if you have 30 shirts. So the 5 turned into a 30. That's times by 6. So I'm going to take the 2, times it by 6. I get 12. Can I do the rest of this chart? Absolutely. If I wanted to, I could go, how did this 2 turn into a 10? I times it by 5. So I'm going to take the 5 and times it by 5 and get 25. How did the 5 turn into 10? Times it by 2, so 2 times 2 is 4. So once you have that simplified ratio, everything else becomes very, very easy in a ratio table, as long as you're looking at the relationships. Let's look at your assignment quickly. All right, so we are looking at your assignment now. And I already know this, that right here, you are having a hard time on your paper seeing these index cards. So look at this page right now. You can see there's 3 index cards, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9 paper clips. And it wants you to write 4 different equivalent ratios that describe the collection picture. So you're looking at that picture. And again, remember, we aren't looking for word form, ratio form, fraction form. We're looking for equivalent ratios. So you're going to write out a ratio. You can simplify, you can multiply it up. However you do it, you've got to come up with 4. Then you're going to be finding the missing value in the ratio charts, just like we did on the other side. Now all of these ratio tables, you need to fill in the boxes. And you'll see, and the reason we've done it this way is so it's easier for you to see on Go Formative. Guys, I think you got a handle on this, especially if you watched me on the practice. So give this a shot. If you have questions, make sure you ask your teacher. All right, guys, until next time.